Hi everyone, welcome to today's GCSE High Revision video. There's 3 weeks to go into your first GCSE Maths exam, and today we're going to be going through the answers to yesterday's practice paper. So yesterday I gave you part 2 of the practice paper, so it had to think about 38 or 40 questions going through topics that we've covered in these 100 days ago videos. I really hope you found it useful going through those topics and those questions, and hopefully giving you a chance to practice each of them again. And in this video I'm going to go through the solutions to every single question, so you can then mark and see if you got each one right, and if you did get one wrong, and most importantly, how to actually get it right and make sure that next time you see that topic, you get that question correct. So let's go through the solutions and I'll speak to you whenever we're finished.
Okay, so let's have a look at question number 1. So question number 1, we've got this triangle, this large triangle, PRT, and then we've got the smaller triangle, PQR, and we've been asked to find the sides of angle X. Now we were told some information in the question. We were told that angle PQS is equal to 50 degrees. So this angle here is 50 degrees. Now you can see here we've got two pairs of parallel lines. So this line's parallel to this line. So that means that this angle is corresponding to this angle. So this angle up here would be 50 degrees also. Now we're also told the angle RTS, so RTS, this angle here, and angle RTU, this angle here, are in the ratio of 3 to 2. So in other words, because this is a straight line, if we share for 180 degrees in the ratio of 3 to 2, we can find the sides of each of these angles. So let's do 3 plus 2, so 3 plus 2 is equal to 5. 180 divided by 5 would be equal to 36 degrees, that's 36 degrees. Now if we want to find the sides of this angle, we're going to do 36 multiplied by 3, and if we want to find the sides of this angle, we'll do 36 multiplied by 2. So let's do that. 36 multiplied by 3 is equal to 108 degrees, so 108 degrees. So this angle here is 108 degrees, and then 36 multiplied by 2 is equal to 72 degrees. So that means that this angle is 72 degrees. Now I've been asked to find the sides of this angle. If we have a look here, we've got a large triangle, PRT. So that means that this angle, and this angle will add together to be 180 degrees. So let's take our 108 and add 50. So that's going to be equal to 158 degrees. And then if we take that away from 180, so 180 subtract 158 is equal to 22 degrees. So that means that X is 22 degrees. And if you got that, well done. Okay, let's look at our next question, question number 2. So question number 2 is to do with gradient. So we've got 2 points, the point 1p and the point 5,1. And we know that the line passing through those 2 points has got a gradient of 3/4. So let's do a little sketch here. So if we just do a little sketch. Okay, so I've just done a little sketch. We've got 2 points. Now I've drawn it this way because I know the gradient's 3/4, so it's got a positive gradient, so it's going to be going upwards. This point here has got the coordinates 1p, and this point here has got coordinates 5,1. Now in terms of this line, if I wanted to find its gradient, I would usually turn it into a little triangle, like so, and then I would do rise over run. Now in terms of the run, if we look at the x coordinates, we've got 1 and 5, so that means the run is 4. We're going 4 across there in terms of the run. In terms of the rise, to find the rise, we would normally take the height of this point and subtract the height of this point to find the rise. So it's going to be 1 subtract p, so that's going to be 1 subtract p. So we now know the run and the rise, so with the gradient m is equal to rise over run, so rise over run. In terms of the rise, that's going to be 1 subtract p, and the run is 4. So that means the gradient is 1 subtract p over 4. Now we've been told that the gradient is actually equal to 3/4, so that means that actually we've got 1 subtract p over 4 is equal to 3/4, because we know the gradient is 3/4. Now if we have a look at this, we can see that the denominators are the same. So that means if we just look at the numerators, this must be equal to 3. So 1 subtract p is equal to 3, because this has to be equal to 3. And then if we solve this equation, so subtract 1 and subtract 1, we're going to get minus p is equal to 2. And that means that p is equal to negative 2. So it means that p is equal to negative 2. And that's it. And we can just check that. If this is equal to negative 2, the run's equal to 4, and the rise would be equal to negative 2 going up to 1 would be 3. And 3 divided by 4 is 3/4. And that's it. So p is equal to negative 2. And if you got that, well done. Okay, let's look at our next question, question number 3. I really like this question, question number 3. It's angles and polygons. So we've got a square, so that's a 90-degree angle, obviously. We've got a regular hexagon. Now the angles in a hexagon add together to be 720 degrees. Now I just know that off by heart. You could use the formula n subtract 2 multiplied by 180. So 6 sides, so 6 take away 2 is 4, times 180 would be equal to 720 degrees. So that's what the angles inside a regular hexagon add up to. So if we divide that by 6, that's equal to 120 degrees. So it means that this is a 120 degree angle here. Now we've got the sides of these two angles. Now in terms of the question, we're asked how many sides the regular polygon has. So we're looking at this regular polygon now. It'd be great if we knew the sides of this angle, and these three angles add together to be 360 degrees. So 120 plus 90 is equal to 210 degrees. So 360 take away 210 is equal to 150 degrees. So that means this is a 150 degree angle. So that means the interior angles in this regular polygon are all 150 degrees. Now, in terms of finding how many sides a polygon has, if we consider the exterior angle, so if we were to look at an exterior angle such as this one, we know that this is 150 degrees, the interior angle. So the exterior angle, remember an interior angle and an exterior angle will always add together to be 180 degrees. That would be 30 degrees. And remember that all the exterior angles will all add together to be 360. So if we take 360 and we divide it by the size of one of the exterior angles, which is 30 degrees, then that would be equal to 12. So it means there's 12 exterior angles, and if there's 12 exterior angles, there's 12 interior angles, and if there's 12 interior angles, there's 12 sides. So how many sides does a regular polygon have? The answer is 12, and if you got that, well done. Okay, let's have a look at our next question. Okay, question number 4 is to do with scatter graphs, and this scatter graph, we've got the time spent in revising and the test score, and we've got hours spent in revising 1.5 and so on, and it goes up to 9 hours. And the question says, explain why it's not sensible to use this scatter graph to estimate the score of a student who spent 15 hours revising. Now, in terms of the time spent revising here, it goes up to 9 hours. 15 hours would be way over here somewhere. And if this is, now if we have a look at the question, it doesn't actually tell us if this is in one particular night, but if this was one particular night and you spend 15 hours revising, you're going to be exhausted and your test score might not actually go up any higher. And actually, even if you were to draw a line of best fit, if you draw a line of best fit, it then might go over 100%, you know. So in terms of the data we've been given, it wouldn't be sensible to use this data to estimate the test score for someone who's revised for 15 hours. So let's explain that. And that's it. I've just said that 15 hours is beyond the range of the given data. The data only goes up to 9 hours, and therefore it would be extrapolation, which is unreliable. So it's not sensible to use that scatter graph to estimate the test score of someone who spent 15 hours revising. And if you got that, well done. Okay, let's have a look at our next question. Okay, let's have a look at our next question. So next question, we've got bag A contains 5x coins and bag B contains 3x coins. So we've got bag A, so bag A, and then bag B, so bag B, and bag A contains 5x coins, and then bag B contains 3x coins, and then we're told that 8 coins are taken out of bag B, so 8 coins are taken out of bag B, so that means that we then have 3x subtract 8 because 8 coins are taken out, and they're put into bag A, so we're putting 8 more coins into bag A, so that's going to be 5x plus 8. So that's how many coins are in each of the bags now. And then we're told the ratio of coins in bag A to bag B is now 11 to 5. So in other words, this to this, so 5x plus 8 to 3x minus 8 is equal to 11 to 5. And we've been asked to find the total number of coins. So what we're going to do is we're going to form an equation using our ratio, because we know that if we multiply this by 5 and this by 11, they'd be equal to each other. And if you go back to the video 40 days to go, and in that video I explain why if you multiply this by that number in the ratio and this by that number in the ratio, why they're equal to each other. So let's do that. So let's multiply this by the second number in the ratio, so 5 bracket 5x plus 8, and that would be equal to this multiplied by that number in the ratio, so 11 bracket 3x subtract 8. So we've now got an equation, we can expand and solve this. So 5 times 5x would be 25x, and then 5 times 8 would be plus 40, and that's equal to 11 times 3x is equal to 33x, and 11 multiplied by minus 8 would be minus 88. Okay, so we've now got this. We want to find out what x is, so I'm going to take the lowest number of x's away from both sides. So I'm going to take 25x away from both sides. So I'm going to subtract 25x from the left-hand side and 25x from the right-hand side. So on the left-hand side, we'd just be left with 40. On the right-hand side, we'd be left with 33x, take away 25x would be 8x, and then we've still got our subtract 88. Now we want to find out what x is, so let's add 88 to both sides of our equation. So adding 88 to the left hand side would be 128, and that's equal to 8x. And then if we've got 8x equals 128, we can divide by 8 and divide by 8 and find out that x is equal to 128 divided by 8 is equal to 16. So x is equal to 16. So that's fantastic. We now know what x is, and the question says work out the total number of coins. So that means that we can either substitute 16 into here and add them together to find the total number of coins. So in other words, how many are in each bag at the end. Or we could go back to the beginning. We could do 5 times 16 and 3 times 16 to find out how many coins were in each bag to begin with. And that's actually what I'm going to do. It's a little bit easier. 5 multiplied by 16 is equal to 80. So originally there were 80 coins in bag A. And in terms of bag B, we're going to do 3 multiplied by 16 is equal to 48. So originally there were 48 coins in bag B. So that means that altogether there are 80 plus 48 is equal to 128 coins. That's how many coins there are. And that's it. And that's it. So that's our answer, 128. And if you got that, well done. So it's really useful to know that how to form an equation if you're given a ratio. Okay, let's have a look at our next question, question number 6. Okay, so question number 6 is a quadratic inequality. So we're going to solve this a quadratic inequality. So whenever you've got a quadratic inequality, we really want this to be 0. So let's take away 42 from both sides. So let's subtract 42 from the left-hand side and 42 from the right-hand side. So on the left-hand side, we'd have x squared, subtract 6x. Now we had 2, we're taking away 42, so that's going to be minus 40. And then we've still got our less than symbol, and then 42, subtract 42 is equal to 0. So we've got x squared, subtract 6x, subtract 40 is less than 0. So that's our quadratic inequality and we want to solve that. So let's sketch y equals x squared, subtract 6x, subtract 40 and see what it looks like. So let's just draw our axes. Okay, so we've got our x-axis and our y-axis. We want to sketch this quadratic graph here. So we want to sketch y equals x squared, subtract 6x minus 40 and see what it looks like. And then ideally we would like to find out when it's below the x-axis. So to sketch this graph, what I'm going to do is I'm going to find where it crosses the x-axis. So I'm going to let y equals 0. So to find where a graph crosses the x-axis, you let y equals 0, the height is 0. So we're going to get that 0 equals x squared subtract 6x subtract 40. And then we're going to factorize it if we can. So let's factorize it. So we'd have x, and then we would have minus 10 and plus 4. So that's fantastic. And that means that x equals 10 or x equals minus 4. So we've got our two values of x equals 10 and x equals minus 4. So the quadratic graph would look something like this, where it crosses the x-axis at minus 4 and 10. Now if we go back to our quadratic inequality, we had x squared minus 6x minus 40 is less than 0. So we want to find the values for x that whenever we substitute them into this, we get a negative value. So in other words, when is this graph below the x-axis? And this graph is below the x-axis for values of x that are bigger than minus 4 but less than 10, any values of x between negative 4 and 10. So that's our answer. X will be bigger than negative 4 but less than 10. And that's it. And if you got that, well done. Okay, let's look at our next question, question number 7. So question number 7 is on composite functions. So we've got f of x, we've got g of x, and we've been given that gf of 2 is equal to 34. And we've been asked to find the value for k. So as I said in the hints yesterday, it'd be handy if we knew the composite function gf of x, because we've got gf of 2. So if we find gf of x, we can then substitute 2 into it. So let's find gf of x. So if we have x and we apply f of x, we get kx plus 3. Then we're going to apply function g, so we're going to substitute this into here for the value for x. So gf of x is equal to 2 bracket, and then instead of x we're going to write kx plus 3 close brackets, and then we've got our subtract 4. So we've just replaced the x with our f of x. Now let's expand our brackets. 2 times kx would be 2kx. 2 times 3 would be plus 6, and then we've still got our minus 4. So that would give us, here we would have 2kx, and then 6 take away 4 is 2, so plus 2. So that means that gf of x is equal to 2kx plus 2. Now in the question we were told that gf of 2 is equal to 34. So let's substitute 2 into this. So let's find gf of 2 and see what that's equal to. So if we substitute 2 in for x, we're going to get 2 times k times 2. Well, 2 times 2 is 4, and then we've got k, so it's going to be 4k, and then we've still got our plus 2, so plus 2. So that means that gf of 2 is equal to 4k plus 2, but we're told that's equal to 34. So that means that 4k plus 2 is equal to 34. And then if we just solve this equation, we'll find k. So let's take away 2 and take away 2, and we get the 4k is equal to 32, and then divide by 4 and divide by 4, and we get that k is equal to 8. So k is equal to 8, and that's it. And if you got that, well done. Okay, so let's have a look at question number 8. So question number 8 is on graphical inequality. So we've got 3 inequalities, so let's draw each of them. So we've got x is less than or equal to 2. So let's draw x equals 2. So x equals 2 looks something like this. So it's a vertical line passing through 2. Now we're told that x is less than or equal to 2. So that means that it's anywhere on the line or to the left of the line. So all the values of x are either on the line or to the left of the line would work. So anything to the right of the line wouldn't work. So I'm just going to put these little lines just to remind myself that I'm rejecting this right hand side, and that anything to the left hand side would work. Okay, next we've got that y is less than or equal to 2x subtract 2. So I'm going to draw y equals 2x subtract 2 to begin with. So to draw this, I'm actually just going to use the intercept and gradient method. So it crosses the y-axis at -2, so it crosses at -2. The gradient's 2, so if I go 1 unit across, now not necessarily 1 box across, in this case it is 1 box, is 1 unit, but we're going to go 1 unit across and up 2. So that's there, 1 unit across and up 2. 1 unit across and up 2, and so on. And now let's get a ruler and pencil and draw a nice straight line through those points. Okay, so that's the line y equals 2x subtract 2. It crosses the y-axis at -2 and has got a gradient of 2. Now we want to find where y is less than or equal to 2x subtract 2. So I'm going to choose a point that's not on the line, so I'm going to choose the origin, and I'm going to substitute into the inequality and see if it works. So 0, and then 2 times x, now x is 0, 2 times 0 is 0, take away 2 would be -2. So is 0 less than or equal to -2? No, it's not. So that means that this is the side we're rejecting, this side doesn't work, and anything below the line works. So I'm just going to do these little lines just to remind myself that I'm rejecting above that line. So anything below the line works and anything above the line doesn't work. Okay, next we're going to draw the graph of x plus y plus 2 equals 0. So we're going to draw x plus y plus 2 equals 0. So I'm going to draw that to begin with, and then we'll find out which side we're rejecting and so on. Now I'm going to make y the subject here, so y equals, and if we take away x from both sides and take away 2 from both sides, we'll get minus x minus 2. So this is a line that's got a gradient of -1 and crosses the y-axis at -2. So it crosses the y-axis at -2 again, so it's going to cross there. But it's got a gradient of -1 here because it's minus x, that means minus 1x. So just to recap there, by the way, I've just taken away x from both sides and taken away 2 from both sides, and I've got this. So the gradient is -1, so that means if I go across 1 unit, I go down 1 unit. If I go across 1 unit, I go down 1 unit, and so on. So that means that the graph would look something like that, and if I go across 1 and up 1 and so on. So it's that line there. So let's draw that line that passes through those points. So that line is x plus y plus 2 equals 0. Now we want to find out what side of this line we're accepting and which side we're rejecting. So again, I'm going to choose the origin and substitute into our inequality. So we've got 0 plus 2 is greater than or equal to 0. So we've got 2 is greater than or equal to 0, and 2 is greater than 0. So that side does work. So that means we're rejecting below that line. So let's reject below that line. And as you can see, we've got a region here that satisfies all 3 inequalities. So the question says clearly label the region. If it said to shade the region in, I would shade that region in. If it says to label it, I'll probably just label it with an R, just show that's the region, and that's it. Okay, let's have a look at question number 9. So question number 9, it's on percentage change. Remember, percentage change is change divided by the original times 100. So in terms of the change here, well, let's work in grams. This is 2,100 grams, 2,100 grams. The bucket, when it's empty, is 800 grams. When it's full of water, it's 2,100 grams. So the change is 1,300 grams. It goes up by 1,300 grams. Divided by the original, well, the original weight of the bucket was 800 grams, so 800 multiplied by 100. So if we do, and it's a calculator question, we're going to do 1,300 divided by 800 and then multiplied by 100, and that's equal to 162.5%. Now the question says give our answer to 2 significant figures, so that means 2 digits followed by 0, so that's going to be 160% to 2 significant figures, and that's it. That's our answer. Okay, let's have a look at our next question, question number 10. Okay, so question number 10 is on transformations of graphs. So we've got this graph and we want to sketch y equals f of x plus 1. So this is a translation and it's inside the brackets as counterintuitive. So rather than moving the graph 1 square to the right, it's going to move the graph or translate it 1 square to the left. So all of these points are going to move 1 square to the left. So that's going to be -5, 0. That's going to be -2, 0. And this is going to be 1, 5. So it's going to look something like this. And that's it. That's what that graph would look like. It's translated the graph 1 square to the left. So this point's moved to -5, 0. This point here is moved to -2, 0, where it touches the x-axis. And this point here, which was 0, 5, is the y-intercept. It's now moved 1 square to the left. So it's now -1, 5. And that's it. Okay, so let's have a look at part B. So part B, we've got y equals f of -x. So that's a reflection, and it's going to be in terms of, because it's inside the brackets, it's going to be a reflection in the y-axis. So all the points that were on the left-hand side, so all the points that were on the left-hand side will move to the right-hand side, and all the points that were on the right-hand side will move to the left-hand side, and any points that were on the y-axis will stay where they are. So let's sketch that. And that's it. So as you can see now, the graph looks like this, where it's coming down. It passes through 0, 5, so it still passes through that point. It goes down and touches 1, 0, comes up, and then goes through 4, 0. So it looks like that. So it's reflected it in the y-axis. And if you got that, well done. Okay, let's have a look at question number 11. So question number 11 is a circle theorems question. We're told that BCDE is a cyclic quadrilateral, and we're told that AB is a tangent to the circle, and that AED is a straight line. And we've been asked to find the sides of this angle Y. So the first thing I notice here, if this is a cyclic quadrilateral, if we add together 28 degrees and 39 degrees, we can find the size of this angle, and then we can take that away from 180 to find the size of this angle over here. So let's do that. 28 plus 39, well, that's going to be equal to 20 plus 30 is equal to 50, plus 8 is 58, plus 9 is equal to 67 degrees. So that's 67 degrees. So that means the angle here on the other side, this angle here, if we do 180 subtract 67, that's equal to 113 degrees. So that means that this angle is 113 degrees, and that means that if we look at this angle here, this one inside this triangle AEB, that's going to be equal to 67 degrees, because that makes a straight line, because 180 take away 113 is equal to 67 degrees. So find the size of that angle. Now what would be fantastic is if we can find the size of this angle here. If we can find the size of that angle, then we've got a triangle and we can find the size of y really easily. Now if we have a look here, this is a tangent and we've got a triangle BEC. So that means that this angle, using alternate segment theorem, is equal to 39. So this angle is equal to 39 degrees. Now just checking, this question doesn't actually ask us to give reasons, but if it asks us to give reasons, we'd have to be listing the reasons here for each of these steps. So this is 39 degrees. We want to find y, so let's add together our 67 and our 39. So 67 plus 39 is equal to 106 degrees. And then 180, take away 106, is equal to 74 degrees. So that means that y is 74 degrees. And if you got that, well done. Okay, let's look at our next question, question number 12. So question number 12 is a quadratic formula question, so it's a calculator question, and we've been asked to solve the equation 4x squared equals 8x plus 7. So we want to solve it to two decimal places. Now it's a quadratic, so let's make it equal to 0. So let's take away 8x from both sides and take away 7 from both sides. And if we do that, we'll get 4x squared minus 8x minus 7 equals 0. Just taking away 8x from both sides and taking away 7 from both sides, making this right hand side equal to 0. Now if we look at this, we know that a is equal to 4, we've got the b is equal to negative 8, and we've got the c is equal to negative 7. So we've got what a, b and c are. Let's substitute them into the quadratic formula to find our values for x. So we've got x is equal to negative b, well b is equal to negative 8, so negative 8 will be 8, plus or minus the square root of b squared, well negative 8 squared, so it's going to be negative 8 squared is 64, because negative 8 times negative 8 is 64. And then we've got subtract, and I like to put the 4ac bit in brackets, so in brackets 4 times a, which is 4, times c, which is minus 7. And then close brackets, and that's all divided by 2a, so 2 times a is equal to 8. So we've got that x is equal to 8 plus or minus the square root of, I'm just going to work out what this is, so 64 minus, and then in brackets 4 times minus 7 is equal to 176, so 176, and then that's all divided by 8. Now we want to find our values for x, so we've got two values. We're going to have 8 plus the square root of 176 divided by 8, and then we're going to have 8 minus the square root of 176 divided by 8. So let's do that. So x is equal to 8 plus the square root of 176 divided by 8, and we've got that x is equal to 8 minus the square root of 176 divided by 8. So let's work those out. So here we've got x is equal to 2.65831 and so on, and here minus 0.65831 and so on. So we've been asked to give our answer to two decimal places. That means that either x is equal to 2.6 and then we've got 5 8, so it's going to be 6, or x equals minus 0.6 and then we've got 5 8, so it'll be 6. So our two solutions to two decimal places, and that's it. And if you got that, well done. Okay, let's have a look at our next question, question number 13. So question number 13, we've got a sphere, a cone and a cube, and we're told the surface area of the sphere is equal to the sum of the surface areas of the cone and the cube. So let's find the surface areas of the cone and the cube, add them together, put that equal to the formula for the surface area of a sphere, and then we'll be able to solve that to find y. So let's find the surface area of the cone and the cube to begin with. So I'm going to start with the cube. It's quite straightforward. So in terms of the surface area of the cube, we've got that the side length of the cube is 8 centimeters. So that's 8 centimeters and 8 centimeters. And 8 times 8 is equal to 64. And there's 6 faces. So each face will have an area of 64 centimeters squared. Let's write that down. 64 centimeters squared. That's the area of each face. So we're going to do 64 multiplied by 6 because there's 6 faces. And that would be equal to 384 centimeters squared. So that's the surface area of the cube. So in terms of the cone, we've got the curved surface on the top and the circle on the bottom. So in terms of the curved surface, that's given to you for the cone. We're told that the curved surface is pi RL. So that's pi times the radius times the slant height, which is 9 in this case, plus, and then we've got the area of the circle on the bottom, so it's going to be pi r squared for the bottom. So whenever we do that, we're going to have pi multiplied by the radius of the base, which is 3, multiplied by the slant height, which is 9. So that's the curved surface there. Plus, so that's the curve, I'm just going to put it in brackets, the area of the circle on the base, that's going to be pi multiplied by the radius squared, so that's going to be 3 squared. So let's work that out. And when we work that out, we get an answer of 36 pi, or as a decimal number, 113.0973355, and so on. So we've got the surface area of the cone, we've got the surface area of the cube, that's actually centimeters squared. We've got the surface area of the cone, we've got the surface area of the cube. Let's add them together to get the total surface area. So 384 plus our 36 pi, or our 113.09 and so on, will be equal to 497.0973 and so on centimeters squared. So that's the combined surface areas of the cube and the cone. Now we're told that's equal to the surface area of the sphere. So let's go down here and let's work this out. So the surface area of a sphere is 4 pi r squared. Well, that's 4 times pi times the radius squared. So the radius in this case is y, so we're going to get 4 times pi times y squared, so 4 pi y squared, is equal to our 497.0973355. Now we just need to solve this to find out what y is. So let's divide both sides by 4 pi, so divide by 4 pi and divide by 4 pi. So the left hand side would be y squared, and the right hand side, if we divide this by 4 pi, just type that into my calculator, is equal to 39.55774,907. So that's the radius squared. We want to find the radius, so we're going to square root that. So y is equal to the square root of 39.55774,907. So that means that y is equal to the square root of answer 6.28949 and so on centimeters. Now the question doesn't ask us to round it to any particular number of decimal places, and I'm going to round that to 4 decimal places. So that'll be 6.2895 centimeters to 4 decimal places. And if you got that, well done. Okay, let's have a look at the next question, question number 14. So question number 14 is a constructions question. So we want to construct the perpendicular to DE through the point F. Now in terms of this question, if you want to watch a video of me showing you how to do it, you can go to corbettmaths.com/contents and scroll down to video number 80. And video number 80 shows you how to construct a perpendicular through a point on a line. Alternatively, you can watch 59 days to go in terms of the 100 days to go videos. In terms of this question, what I probably would do is I put the point of my compass on F, and I would set my pencil to E. And then what I would do is I would do a little arc here, and then I would do an arc on the other side. And what that means is that whenever you do that arc, where the arc crosses the line, would be the same distance from here to F as it would be from F to E. Then you can construct the perpendicular bisector of this line here, from here to here. So you can put the point of the compass here, set it over halfway of the line. So then sort of you can do your arc above and below, so the arc here and the arc there. And then you can turn the compass around, keeping it the same size, putting the point of the compass on E, setting it over. Again, it would be over halfway, and then do the arc above and below, and then whenever you join those up, it would be perpendicular to DE, and it would pass through the point F. Okay, so question number 15 is a pie charts question. Now in terms of this question, we've got this pie chart, and we're told that 1,016 more people voted for the yellow party than the purple party. There's probably a few different ways you could do this question. The way I would approach it is I would work out the sides of this angle here. That's a pie chart, so the degrees will add up to be 360 degrees. That means that's 220 degrees. Now we know 1,016 more people voted for the yellow party than the purple party, so that means that the difference between them would be 1,016. So I'm going to take the degrees away from each other. I'm going to do 220 subtract 140 degrees, and that would be equal to 80 degrees. So that means that 80 degrees, the difference between them would be 1,016 people in terms of this pie chart. So 80 degrees represents 1,016 people. So if 80 degrees represents 1,016 people, we want to find the total number of votes. We want to find out what 360 is. So I'm going to divide both of these by 8. So if I divide by 8 and divide by 8, I can find out how many people are represented by 10 degrees in my pie chart. So 1,016 divided by 8 is equal to 127. And then if we multiply by 36 and multiply by 36, we can see what 360 represents in our pie chart. So 127 multiplied by 36 is equal to 4,572. So that means the pie chart represents 4,572 people, or votes in this case. And that's it. And if you got that, well done. Okay, question number 16. We've been asked to sketch the graph of y equals cos x. So y equals cos x, it'll pass through 1 and 0 and -1 and 0 and 1. And if you know your cos graph, you'll know it looks like this, and then you just draw your curve through it, so it looks like this. And that's it. Your sketch should look something like that. Okay, let's look at our next question, question number 17. So question number 17 is nonlinear simultaneous equations. So what we're going to do is, let's make x or y the subject of the second equation. I'm going to make x a subject. So if I take away y and take away y, we would get that x is equal to 7 subtract y. Now we're going to substitute that into our top equation for x. So we're going to substitute it in here. So we're going to get 7 subtract y in brackets squared plus y squared equals 25. Now let's expand this. So then we're going to write the bracket out twice. 7 take away y and 7 take away y. And then we've still got our plus y squared equals 25. Expanding our bracket, 7 times 7 is 49. 7 times minus y would be minus 7y. Minus y times 7 will be minus 7y, and minus y times minus y will be plus y squared. And then we've still got our plus y squared, and then that's equal to 25. Simplifying this will give us 49, take away 14y plus 2y squared equals 25. I'm now just going to go up here. So then we would have, let's just write it out again, 49 minus 14y plus 2y squared equals 25. Now I'm going to rearrange this slightly. I'm going to put my 2y squared at the front, and then I've got my minus 14y, and then we've got our plus 49, and that equals 25. And I'm going to take away 25 and take away 25, so that would leave us with 2y squared minus 14y, and then 49 take away 25 will be plus 24 is equal to 0. Now let's divide everything here by 2, so we're going to get that y squared minus 7y plus 12 is equal to 0. Now let's factorize this, so that would give us y minus 3 minus 4. So that means that y is equal to 3 or y is equal to 4. Now if we substitute those back into our top equations, if we had y is equal to 3, we're going to get x plus 3 is equal to 7, so that would be x is equal to 4. And in this case, if y is equal to 4, we then get x is equal to 3. And there will be our solutions, that y equals 3 and x equals 4, or y equals 4 and x equals 3. And that's it. And if you got those, well done. Okay, so let's have a look at question number 18. So question number 18 is on 3D trigonometry and Pythagoras. And part A, we've been asked to calculate the height of the pyramid. So we want to find the height of the pyramid. So that's going to be this height here. So I'm just going to draw a little triangle like so. And we're told that the apex is directly above the center of the base. So I'm going to call the center of the base M. And I'm going to draw a little right angle triangle like so. So we've got this right angle triangle. We know that EC is equal to 11 centimeters. It would be great if we could find the distance of MC or CM. And then we could use Pythagoras to find the height of it, ME. So let's find the distance AC. So that's the diagonal distance across the base, like so. So that's a right angle triangle there. We've got CD is 6 centimeters and AD is equal to 8 centimeters, and we want to find AC. So let's sketch that triangle. And we've got A, C, and D. And we know that AD is equal to 8 centimeters, that CD is equal to 6 centimeters, and the AC, that's what we're trying to find, the whole diagonal there. Let's use, that's a right angle triangle, so let's use Pythagoras' theorem. So A squared plus B squared equals C squared. So we've got 8 squared plus 6 squared is equal to x squared. 64 plus 36, that's 100, is equal to x squared. So that means that x is equal to 10. So that's equal to 10 centimeters. And actually thinking about it, a 3, 4, 5 triangle, if you double them, would be 6, 8, 10. So that if the whole distance across diagonally is 10 centimeters, that means that MC would be 5 centimeters, the distance from M to C. So we've now got this triangle, MEC, and we know that what two of the lengths are, and it's a right angle triangle, so we can use Pythagoras again. So let's do that. So let's draw the triangle EMC, and I'm just going to draw it over here. So this is the right angle triangle EMC, where E is the top of the pyramid, M is the center of the base, and C is that corner there of the pyramid. And we know that EC is 11 centimeters, MC is equal to 5 centimeters, and we want to find this, the height of the pyramid. So let's label our sides. Pythagoras' theorem is A squared plus B squared equals C squared. The two shorter sides are A and B, so let's call that A, that B, and the longest side, the hypotenuse, is C. So A squared, that'll be 5 squared plus B squared, that's x squared, is equal to C squared, that's 11 squared. 5 squared is 25, so we're going to get 25 plus x squared equals 121, and that means that x squared would be equal to 96, and that means if we square root this, we're going to get that x is equal to the square root of 96, and the square root of 96 is equal to 4 root 6, so x is equal to 4 root 6 centimeters, and as a decimal number that would be 9.79795891, and so on. And let's just write that, and let's write that down, and let's round it to 3 decimal places. So that would be 9.798 centimeters to 3 decimal places. And part B says calculate the size of the angle between face ABE and the base ABCD. So we want to find the angle between this face and the base. That's going to be that angle. And I'm just going to rub some of this out so we can see it a bit clearer on the diagram. Okay, so I've just sketched this triangle. I'm going to call P the midpoint of AB. And we want to find the angle between this face and the base. So if we draw this right angle triangle where we've got M the midpoint of the base, E is the top of the pyramid, and P is the midpoint of AB. And the angle between EP and MP, this angle here, would be the angle between that face and the base. So we want to find the size of that angle. I'm going to call it beta. So we've got PM. PM would be half of it. That's going to be 4 centimeters. And ME, well, we've worked that out before. That is equal to the square root of 96. And I'm going to write it as a third, the square root of 96, rather than the decimal number, because if we round this, we might lose a bit of accuracy. So I'm going to leave it as the square root of 96. So we've got a right angle triangle, and we've got this right angle triangle. If we work out the size of this angle, that's the angle between the face and the base. So let's sketch out our triangle. Okay, so we've just sketched out the triangle, and we want to find the size of this angle, so let's label the sides. The side opposite it would be the opposite. The hypotenuse is this side, and the adjacent would be this side. We want to find the sides of the angle, so we don't need them. We're not trying to find the hypotenuse, so let's cross that off, and we're going to be using the opposite and the adjacent. So that's going to be tan. The tan of the angle is equal to the opposite divided by the adjacent. And let's substitute those into our trig ratio. So we're going to get the tan of the angle is equal to the opposite, which is root 96 divided by 4. And that means that beta would be equal to the inverse tan of root 96 over 4. And when we type that into our calculator, we get that beta is equal to 67.7923 and so on degrees. And let's just round that to 2 decimal places. That'll be 67.79 degrees. And that's it. And if you got that, well done. So question number 19. So question number 19 is on iteration, and part A is to rearrange this equation to give us this. Well, if we have a look at it, we've got 5 over x squared and minus 3. Now, if we look at the minus 3, it looks like we've divided through by x squared and then rearranged it. So let's do that. So let's take our equation, x cubed plus 3x squared plus 5 equals 0. And let's divide everything by x squared. So that will give us x plus 3 plus 5 over x squared equals 0. So we want to make x a subject, so let's take away 3 from both sides. So if we take away 3 from both sides, we'd get x plus 5 over x squared is equal to negative 3. And then if we take away our 5 over x squared and take away 5 over x squared, we're going to get our x equals minus 3 minus 5 over x squared. And that's it. Okay, let's have a look at part B. So part B, we've been given this iteration formula. We've been given that xn plus 1 equals negative 3 minus 5 over xn squared. And we've been asked to start with x0 equals negative 4. And we've been asked to find x1, x2, and x3. Okay, so to find x1, so x1 will be equal to minus 3 minus 5 over x0 squared. So we're going to substitute negative 4 into this. So we're going to get x1 is equal to negative 3 minus 5 over minus 4 squared. So let's type that into our calculator and see what we get. So x1 equals negative 3.3125. So to find x1, now what we're going to do is we're going to find x2. So actually let's write x1 in here, minus 3.3125. So x2 will be equal to minus 3 minus 5 over x1 squared. So we're now going to substitute this into our iteration formula for the value for x1 and see what we get. So x2 will be equal to minus 3.45567 8177. So that's our value for x2, minus 3.455678177. So we found our values for x1 and x2. Now let's find x3. So x3 will be equal to minus 3 minus 5 over x2 squared. And if we substitute this in for our value for x2, we get x3 is equal to minus 3.418700446, and that's it. We found x3 as well, so minus 3.418700446, and that's it. We found our values for x1, x2, and x3, and that's it. Okay, in part C, we're asked to find the relationship between our values of x1, x2, and x3, and the equation x cubed plus 3x squared plus 5 equals 0. Well, if we have a look, our iteration formula was found by rearranging that equation. So these values of x1, x2, and x3 are going to be increasingly accurate approximations to a solution to this equation. So let's write that. And that's it. And I've written down there, increasingly accurate approximations to a solution of x cubed plus 3x squared plus 5 equals 0. Okay, let's look at our next question. So question number 20, it's a quadratic nth term, and we've been given a sequence 3, 14, 31 and 54. So 3, 14, 31 and 54. And we've been asked to find the quadratic nth term of that sequence. So let's write down our first differences and our second differences. So our first differences will be 11 and then 17 and then 23. And our second differences will be 6 and 6. So we've got our sequence, our first differences and our second differences. Now we know a quadratic nth term will be in the form an squared plus bn plus c. So that's the quadratic nth term. And let's find our values for a, b and c. Okay, so remember that our second difference is equal to 2a, our first difference is equal to 3a plus b, and our first term of the sequence will be a plus b plus c. So there are different ways to approach this quadratic nth term, and if you do want to look at the other approaches, go to Corbettmaths.com, and I've got 3 different videos on how to find the quadratic nth term. I tend to use this approach, but obviously if you use a different approach and you get the right answer, that's totally fine. So we've got the 2a equals 6, so 2a equals 6, and if we divide both sides by 2, we get a is equal to 3. Next, we've got 3a plus b is equal to 11. Now 3a, 3 times 3 is equal to 9, so we're going to get 9 plus b is equal to 11. Taking away 9 will give us b is equal to 2. And finally, a plus b plus c is equal to 3. So a is equal to 3, and b is equal to 2, and then we've got plus c is equal to 3. So we've got 5 plus c is equal to 3, so that means that c is equal to negative 2. So we've got our values for a, b and c. So that means our quadratic term will be 3n squared plus 2n subtract 2. And that's it. And if you got that, well done. Okay, let's look at our next question, question number 21. So question number 21, we've been asked to reflect this triangle C in the line y equals negative x. So we're going to draw the line y equals negative x. So remember, the line y equals negative x will have a gradient of negative 1 and pass through the origin. So it looks something like that. That's our mirror line. And now we just need to plot each of the points after we reflect them. So let's start off with this one. To get to the mirror line, it's one diagonal. So we're going to go another diagonal. So that'll be there. This point here, it's 1.5 diagonals to the mirror line. So we're going to go a half 1 to there. And this point, it's 1, 2.5 diagonals to the mirror line, so we're going to go a half 1, 2. So that's going to be there. And now we just need to join them up. And that's it. We've reflected the triangle in the mirror line y equals negative x. And if you got that, well done. Okay, let's look at our next question, question number 22. Okay, let's have a look at question number 22. So we've got these distances, and we've been asked how far does Matthew run in total. So we've got 1.5 plus 1 2/3 miles plus 2 1/5 miles. And we just need to add them all up. So let's do that. So to begin with, we're going to make them all top heavy. So that's going to be 3 halves plus 1 times 3 is equal to 3 plus 2 is 5. So it's 5/3. Just to recap, this one was 1 times 2 is 2 plus 1 is 3. So 3 halves plus 2 times 5 is 10 plus 1 is 11. So 11/5. So we've got all our fractions as top heavy fractions. Now let's find a common denominator. So a common denominator of 2, 3 and 5. So I'm thinking 30. So I'm going to go for 30, 30 and 30. So to get from 2 to 30, we multiply by 15. So let's multiply the numerator by 15. 3 times 15 is 45. To get from 3 to 30, we multiply by 10. So we multiply the numerator by 10, we get 50. And to get from 5 to 30, we multiply by 6. Then we're adding those together. So our answer will be over 30. And let's just find the numerator, 45, 50, and 66. And let's add them up. 5 plus 0 is 5, plus 6 is 11. So 1, carry 1. 5 plus 4 is equal to 9, plus 1 is equal to 10, plus 6 is equal to 16. So it's 161 over 30. And let's change that into a mixed number. How many 30s go into 161? That's going to be 5. Remainder 11 over 30. So it's 5 and 11/30ths of a mile. And that's it. And if you got that, well done. Okay, let's have a look at our next question. Okay, so question number 23, it's on enlargements and using negative scale factors. We've been asked to use the origin as a centre of enlargement, so I've done that, and the scale factor is -2. Okay, so let's look at each of the points, and let's go twice as far away, but in the opposite direction. So this point here is 1 to the right and 1 up. So we're going to go 2 to the left and 2 down. So it's going to move to there. This point here, it's 3 to the right and 1 up. So we're going to go 6 to the left and 2 down. So it's going to move to there. This point up here, it's 1 to the right and 2 up. So we're going to go 2 to the right and 4 down. So it's going to move to there. And this point up here, it's 3 to the right and 2 up. So we're going to go 6 to the left and 4 down. So it's going to move to there. So we've got our points. Now we just need to draw our lines. So it's going to look something like this. And that's it. We've enlarged this triangle by scale factor -2 using the origin as the centre of enlargement. And that's it. Okay, question number 24. We've been asked to rationalise the denominator of 12 over root 3. So to rationalise the denominator, we want to get rid of this third on the denominator. And remember that if we multiply a third by itself, so if we do root 3 times root 3, that's equal to 3. So if we multiply both the numerator and the denominator by root 3, we'll rationalise that denominator. So 12 times root 3 is 12 root 3. And on the bottom, root 3 times root 3 is 3. So you've got 12 root 3 over 3. Now 12 divided by 3 is 4, so that'll be 4 lots of root 3. And that's it, 4 root 3. We've rationalised it. Okay, let's have a look at question number 25. So question number 25, we've got this graph and it shows us the depth of water in centimetres t seconds after the start of filling in the container. So we've got a container, and as time progresses, the depth of the water goes up. So this container's been filled up, and part A says estimate the gradient of the graph whenever t is equal to 15. So we're going to draw a tangent at t is equal to 15, and we want to find its gradient. So let's do that. Okay, so just drawing a tangent. Now obviously my tangent may be slightly different than your tangent. Whenever you're doing these questions in the exam, you're allowed slightly different tangents because you're doing it by hand. You're just sort of trying to guess where the tangent is. So we've drawn this tangent at the point t is equal to 15. So at this particular point here, we've drawn our tangent. So let's find the gradient of this tangent, and that'll tell us the rate of change, or the question says to find the gradient of the graph. So if we find the gradient of the tangent, it's the same as the gradient of the graph at that particular moment. So I'm going to choose 2 points on that tangent. So I'm going to choose this point here. So that's the point 0. And then if we look at the height, we've got 2 little boxes above 1. So we've got 1, and we're going to divide it by 10. That's going to be equal to 0.1. So it's going to be 1.1, 1.2. So the height of this point is 1.2. So we've got 0, 1.2. And then another point I'm going to choose is I'm going to choose this point here. So this point here is 25 across, and then in terms of its height, it's 2 little boxes below 5, so it's going to be 4.9, 4.8, so 4.8. So we've got the point 0, 1.2, and 25, 4.8. So let's find the gradient. So remember, gradient m is equal to rise divided by run, so rise over run. Now the rise, well, the rise, we're going from height, if we actually turn this into our little triangle. Okay, so the run's going to be 25, and the rise, we're going from a height of 1.2 up to 4.8, so the rise is going to be 3.6. So we've got 3.6 divided by 25, and 3.6 divided by 25 is equal to 0.144. So I've got 0.144 as the gradient of the graph at 15 seconds. And if you got that, well done. Or if you got something similar to that, well done. Okay, part B. Part B says describe fully what our answer to A represents. So if we look at this, we've got the depth of the water in the container and time. So that means that we're looking at the depth of the water at any particular moment. And that means the gradient will be the rate of change. So it's how the depth is changing at that particular minute. The water, the depth is increasing by 0.144 centimeters at that particular moment. So it's the rate of change of the depth in the container. So let's explain that. And I've just written down it's the rate of change of the depth of water at t is equal to 15. Okay, and part C says explain why A is only an estimate. Well, we could think of how we drew that tangent. Our tangents may be all slightly different because we've just drawn it manually. So let's explain that. And that's it. So I've just written down we've had to judge where the tangent is. So our answer is not exact. It's an estimate. Okay, let's look at our next question. Okay, question number 26. This is an algebraic proof. So we've been asked to prove that this is always a multiple of 4. So let's expand our brackets. Okay, so I've written the brackets out beside themselves because whenever we're squaring something, we're multiplying it by itself. So we're going to do 2n times 2n is 4n squared. 2n times 9 is plus 18n. 9 times 2n is plus 18n. And 9 times 9 is 81, so plus 81. So we've expanded our first pair of brackets. Now let's expand our second pair of brackets. I'm going to put a minus sign, and then I'm going to put a bracket here, and I'm going to expand this and put our answer inside of a bracket, just because we're subtracting all of this. So 2n times 2n is 4n squared. 2n times 5 would be plus 10n, and again plus 10n, and then 5 times 5 is 25, so plus 25. And then we've got, if we simplify this, we'll get 4n squared plus 36n plus 81. Subtract, and then let's simplify this, 4n squared plus 20n plus 25. Now we just need to subtract, so we're subtracting all of this from this. So 4n squared take away 4n squared will be 0. 36n take away 20 will be 16n. 81 take away 25, well, 81 take away 25 is equal to 56, so that'll be plus 56. And then we've been asked to show this is always a multiple of 4. So as you can see here, we can factorize this and take 4 out. So that would be 4 bracket 4n plus 14. And so that means that this is equal to 4 bracket 4n plus 14. So it's 4 multiplied by something, so it's a multiple of 4. So let's explain that. And so because it's 4 multiplied by something, it's always going to be a multiple of 4. So therefore, it's always a multiple of 4. Okay, so let's have a look at question number 27. So question number 27 is an arc length, and we're told the perimeter of this sector is 1 meter or 100 centimeters. And we've been asked to find y, the radius of the circle. So what I'm going to do is I'm going to find an expression for the perimeter of this sector and then put it equal to 100 and then find y. So let's do that. So in terms of the arc length, that's going to be beta, remember beta over 360 multiplied by pi multiplied by the diameter. That's how we find the arc length from here around to here. So that would be, in this case, this angle is 230 degrees because they have to add together to be 360. So 230 over 360 multiplied by pi multiplied by the diameter of the circle, which will be 2y. So 2y is the whole way across. And then obviously to find the whole perimeter, that would be from here around to here, but then we'd need to add on y and another y. So then we'd be adding on y and adding on another y. Now let's simplify this. It's a calculator question, so I'm going to do this part on my calculator. So I'm going to do 230 over 360 and then multiply that by pi. And then I'm going to multiply that by 2. So multiplying everything in front of this y. And that would be equal to 23/18 pi y. So that'll be equal to 23 over 18 pi y if you type this part into your calculator. And then we're adding 2y, so it's going to be plus 2y. And that's equal to 100. So we've got the arc length plus the 2 radii equals 100. Now I'm actually just going to simplify this. We've got this many lots of y plus 2. So if I just add 2 to this, that gives us, that's equal to 6.0142578y. So just to recap that, we have so many lots of y and so many lots of y. Ordinarily, we just add those together. So my calculator, I already had this on my calculator display. So I've just then pressed plus 2, and then that's given me 6.014 and so on, lots of y, and that's equal to 100. Now I want to find out what y is, so let's just divide by this and divide by this. So let's just divide both sides by this. That'll be divide by 6.014 and so on, and divide by 6.014 and so on. So on the left hand side we'll get y, and on the right hand side we'll have 100 divided by answer is equal to 16.627157 centimeters, and that's it. That's the value for y. And let's just round that. I'm going to round that to 2 decimal places. That'll be 16.63 to 2 dp, to 2 decimal places. And if you got that, well done. Okay, let's look at our next question. Okay, so question number 28, we've been asked to draw a box plot. So I'm just going to draw this box plot now because we've got the lowest, the lower quartile, median, upper quartile, and highest. So we don't need to work anything out. We just need to plot them. I'm just going to do a scale here, 50 kilograms, 60 kilograms, and that's it. So I've just drawn our box plot. So we've got 68 kilograms, we've got 74 kilograms, 82 kilograms, 88 kilograms, and 100 kilograms. And I've joined up the lower quartile, median, and upper quartile, like so, as a box. And then I've drawn lines to the two ends, the two whiskers, I suppose. Some people call it a box and whisker diagram. So I've joined it up to the lowest value and to the highest value with those lines. And that's it. That's the box plot in part A. And part B, okay, so in terms of the box plot for the female rugby players, we've then got the lightest weight's 51. That's fantastic. So we've got the lightest. The lower quartile is 60 and the median is 71. So actually, let's draw those to begin with. Okay, so we've drawn the lowest weight, which is 51 kilograms, the lower quartile, which is 60 kilograms, and the median, which is 71 kilograms. Now then, to find the upper quartile and the highest value, we need to read the next bit of information. It says the range and the interquartile range of the female rugby players is the same as the male rugby players. So let's go up to the female rugby players and find the interquartile range and the range. So the interquartile range, the IQR, the interquartile range, is found by either taking away the lower quartile and the upper quartile by looking at the box and finding out how far apart they are, or we can look at these values and we can do 88 take away 74, and 88 subtract 74 is equal to 14 kilograms. So that means the interquartile range is 14 kilograms, and actually if you look at the box plot you'll see that they're 14 kilograms apart. So the interquartile range is 14, and the range, if we work out the range, remember that's the biggest take away the smallest, so 100 take away 68. So 100 take away 68 is equal to 32 kilograms. So the range is 32 kilograms and the interquartile range is 14 kilograms. So let's write that down. The interquartile range is 14 kilograms and the range is equal to 32 kilograms. So let's use the range to begin with. If the lightest weight is 51, if we add the 32, that'll give us the heaviest rugby player, the heaviest female rugby player, and that's equal to 83 kilograms. So that's going to be the highest weight. And in terms of the upper quartile, well, the lower quartile is 60, and if we add on the interquartile range, which is 14, we can then find the upper quartile, which is 74 kilograms. So we've got the highest and we've got the upper quartile. So now let's plot those. And that's it. So as you can see from our box plot, we've got the lightest rugby player, which is 51 kilograms, the lower quartile, which is 60, the median, which is 71, the upper quartile, which is equal to 74 kilograms, and the heaviest female rugby player is equal to 83 kilograms. And if you got that, well done. Okay, let's look at our next question. Okay, let's look at our next question, question number 29. We've got the bearing of Q from P is 070 degrees, and we've got a diagram which is quite nice, and we want to find the back bearing. Now, there's a couple of approaches we could use here. With this bearing, we could just add 180 and get 250 degrees straight away. To find a back bearing, you can, if it's less than 180, you can add 180, and if it's bigger than 180 or 180 and larger, you can then just take 180 away, and it'll tell you the back bearing. So the back bearing is going to be 250 degrees. Alternatively, you can use this diagram. And if we've got P and Q, and we've got the bearing of Q from P, so that angle is 70 degrees, I've just written 70 degrees, and we want to find the bearing of P from Q, so we want to find the sides of this angle. Now, considering your co-interior angles, the north lines are parallel. That means that this angle and this angle would add together to be 180, so this angle is 110 degrees. The angle on the outside then would be 250, so that means the bearing, measured clockwise from north or around, from the north line around to the line joining Q and P, would be 250 degrees. So the bearing is 250 degrees. And that's it. And if you got that, well done. Okay, let's look at our next question, question 30, and we've been asked to calculate the area of a triangle. In the hint video yesterday, I explained that the area of a triangle can be found by using half AB sine C. So that's if you've got two sides and the angle in between them, you can use half AB sine C. So it's going to be a half multiplied by A and B, which would be 6 and 7. It doesn't actually matter which way around you write those. Multiplied by the sine of 60 degrees. And whenever we type that into our calculator, we get that's equal to 21 root 3 over 2, or as a decimal number, 18.1865, and so on. And let's just round that to 3 decimal places. That'll be 18.187 centimeters squared to 3 decimal places. And that's it. And if you got that, well done. Okay, let's look at our next question, question number 31. Okay, question number 31, we've been asked to find the length of BC. Now, this is a sine rule question because we've got the size of an angle and the length of the side opposite it. So we're going to use that to then find the length of BC. So let's call that x, and let's use the sine rule. So remember, the sine rule is a over sine A equals b over sine b. So that means that if we substitute these values in, so A and capital A are the side and the angle opposite each other. So in this case, I'm going to say that x over sine 33, so x over sine 33, will be equal to 15 over sine 112. So we've now got this. We can work out the right-hand side. We can do this division to get that. X over sine 33 is equal to, and then if we do 15 divided by the sine of 112, that's equal to 16.178, and so on. Now we want to find out what x is, so let's multiply both sides by the sine of 33. So multiply by sine 33 and multiply by sine 33. So on the left hand side we'd get x, and on the right hand side we'd have 16.178 and so on, multiplied by the sine of 33 degrees. And whenever we type that into our calculator, we can just do multiply by the sine of 33, and we get that x is equal to 8.811181, and so on, centimeters. So b is equal to 8.81 centimeters to 2 decimal places, And if you got that, well done. Okay, let's look at our next question. Okay, let's have a look at question number 33. So question number 33, we've been given a circle, and we've got this tangent to the circle at the point 68, and we've been asked to find the equation of that tangent. Now, in the hint video yesterday, I said what we'd do is we'd consider the radius, and if we find the gradient of the radius, we can find the gradient of the tangent. So let's find the gradient of the radius. So let's look at this radius, and it makes a right angle triangle, like so, and the run would be from 0, 0 to 68 will be 6 across, so the run 6, and the rise go from a height of 0 up to 8 would be 8. And then the gradient m is equal to rise over run, so that's going to be 8 over 6, and that's equal to 4/3. So the gradient of the radius is 4/3. So that means the gradient of the tangent would be the negative reciprocal. So that means for this tangent, m would be equal to negative 3/4, doing the negative reciprocal to find the gradient of that tangent. So that means that y is equal to negative 3/4 x plus c. Now we're going to substitute in our coordinates 6, 8 into this to find our c. So instead of y, we're going to write 8 is equal to minus 3/4 of x, and x is 6, so minus 3/4 of 6 plus c. And then we just need to work out what c is. So let's get our calculator and work out this part. So minus 3/4 multiplied by 6 is equal to, x is equal to minus 9/2 plus c. And then if we add 9/2 to both sides here, so if we add 9/2 or 4.2, we get that c is equal to 8 plus 9/2 25 halves, or 12.5, and that's it. So we've got the equation of the tangent. Remember, it's y equals mx plus c. We know the gradient of the tangent is -3/4, so we'd have y is equal to -3/4 x plus, and then 25 halves. Now you might have written it as decimals. You may have written y equals -0.75 x plus 12.5. That would be fine also. And that's it, either one of those. And that's it. And if you got that, well done.
And that's it. So in this video, we've gone through the video solutions, that second practice paper. I really hope you found it useful in terms of knowing what your strengths are and what topics you're really good at. But also, most importantly, if you've got some questions wrong, identifying what topics they are, and then you can do something about it with 3 weeks to go. You can watch the Corbettmaths video tutorials, you can do the practice paper questions, you can do the textbook exercises. You can, if you've got the revision cards, go through the revision cards, look at your cheat sheet, look and see your bedroom window with your window pens and see if you've got notes on it in terms of those particular topics. Also, you can perhaps, if for instance a topic maybe like the cosine rule that you got wrong, then you can go and speak to your teacher and say, look, can you just go through this with me again and give me some questions on it? So with 3 weeks to go, there's lots of time to be able to go through and do some work and target those areas where you've maybe got questions wrong. But keep up the hard work. You're doing really, really well. Tomorrow I'm going to be going through another topic, and we're going through a few more topics. Those last few topics before we get to the end. And then also be part 3 in terms of this practice paper. So there'll be another practice paper, and it's a bit of a shorter one as we get a bit closer. And then I'm going to be doing lots of videos in terms of there's going to be a quiz, there's going to be recaps of number topics, algebra topics, geometry topics, and shape, space, and measure topics, and your statistics and probability topics as well. So keep up the hard work, and I'll see you tomorrow for the next video on YouTube at 3 o'clock. Cheers. Bye.